Hello, how are you? Again, my name is Martin Wachie, and thank you for joining me in this quick revision. Today, we are going to tackle probability. Probability theory is one of the topics I think that is done in Form 3, and it is very common in exams and quite easy. So I'm assuming you've done probability in class, and if you need to understand some theoretical aspects of probability, just go back to your notes and revise. Because for me, I'm going to just get direct to examples and some questions that you saw. So I'll share my screen with you once again. I got this questions online. I hope they are legitimate, but at least they are good examples we can use to understand this theory. So these are some of the questions that we are going to handle. And we'll start with the first one. So we say that the probability that a husband and a wife will be alive 25 years from now are 0.7 and 0.9 respectively. So find the probability that in 25 years, one, both will be alive, two, neither will be alive, C, one will be alive, then D, sorry for that, and D, at least one will be alive. So let me try to, so at least one will be alive. So from here, let me just, there's no need of having me there on the video. Let me just turn it down like this. Sorry for that. And here we will get to share the whiteboard with you. So we have the probability that husband alive 5 years from now. Then the same thing. So you can just, to make our notation easy for presentation, you can just have it indicated as probability that husband will be alive as sorry for that, 0.7. Then for the wife, probability that wife will be alive 25 years. Let's call it probability that wife will be alive 25 years is 0.9. So those are the probabilities. So of course, there is probability that husband will not be alive. So the husband will be, let me just be rude and write dead. Present probability that husband will not be alive. So it will be 1 minus probability that husband is alive in 25 years. So that is 0.3. Then same thing to probability that wife will be dead in 25 years will be probability that wife is dead 25 years, that is minus 0.9, sorry, that is 0.1. So we have that. We can just go back and look at our question again. So the question is, Now find the probability that both will be alive. B, neither will be alive. C, one will be alive. D, at least one will be alive. So both will be alive, neither will be alive. Let's start with those two. So we have, we have A, probability both will be alive. B, probability that neither will be alive. Then we have C, probability that one will be alive, and D, at least one. D is the probability that at least one will be alive. So we get to that. So D is that at least one will be alive. That is, those are some of the questions that probably you need to understand, and they'll look similar to that one, but don't cram, just practice, understand the concept and everything. So one thing I want to explain here before I calculate, if it doesn't matter if the husband dies, it doesn't mean the wife will die, or the husband dying has no relationship with the wife dying. So these are called independent events. Like, they have no relationship. They're independent from each other. The husband can die anytime. The wife can die anytime. They do not. The two do not affect each other. Of course, in real life, we know things are different. It's conditional. Sometimes a partner will die because of losing their own, but we are not doing that here. So let's start the probability that both will be alive. So solution A is probability that both alive. So probability that both will be alive is probability that wife is alive and probability that husband is alive. So remember, I'm saying and. So the probability that wife is alive and probability that husband is alive. So that becomes, let me just write it, probability wife is alive and husband is alive. So and here, these are independent events, so this can be represented as probability of wife being alive times probability of husband being alive. And probability of wife being alive is 0.9 times probability of husband being alive is 0.7. This gives us 0.63. That is the first one. Then probability that both are dead or both will not be alive. So B, probability both are not alive. So this one will be probability that husband is not alive and also wife is not alive. So that is and. They must, both of them are not alive. So this is just probability husband is not alive times probability that wife is not alive. So I'm using that symbol to show the apostrophe to show they're not alive. So for the husband not alive, you had seen it 0.3. For the wife is 0.1. 3 times 0.1 is 0.03. What will be the probability that both will not be live when that time comes? Is it? Okay. The probability that the next next is C. The probability that one will be alive. So probability that one will be alive is some doubt I have here, but can always correct. So probability that one will be alive is the probability that husband is alive, wife is dead, or probability that husband is dead, wife is alive. So probability that husband is alive is 0.7, wife is 0.1. Or now add probability that husband is dead is 0.3. Probability that wife is alive is 0.9. That one becomes 0.07 plus 0.27, which gives us our answer as 0.34. 0.34. Then probability number D, one alive. At least one is alive. So at least one is alive. This can be both of them are alive. So husband is alive, wife is alive. Or husband is alive, wife is dead. Or husband is dead, wife is alive. So in all of them, at least one is alive. So here, two of them are alive. Then the next one is alive. Uh, Husband is alive. Then the next one, wife is alive. So there, at least one is alive, and you get that. So here you will get your 0.7 and husband alive is 0.7 times 0 point husband dead is 0.3 times wife alive is 0.9. So these ones you can get them from here, our probabilities that we had come up with from the question. So this one gives you 0.63 plus 0.07 plus 0.27. So the solution here is this is 10, 17. Then 2 plus 0, that is 3, plus 6 is 9. So it's 0.7. But this is a long way of doing it. So alternatively, you can do this for D. Let me just do it on So probability that at least one is alive is equal to probability is equals to 1 minus, so at least one is alive. That means you see from here, let me just show you. From here, you've seen that at least one is alive. So all the occurrences are there except one, when both are not alive, when both are dead. So this is the only one missing. So we have, so the same thing, you can either solve it part B like this, or the shortest method is like this. So think at least one is alive is probability, it's 1 minus probability of both dead. Sorry. So which is 1 minus probability of husband not alive, wife not alive, which is 1 minus probability of husband not alive is 0.3 and wife not alive is 0.1. This is 1 minus 0.03, which is equals to what? 790. So you have your answer, 0.97. So that question, I think, most likely is a section B question that will give you so many in your exam. So just to go through. So these are some of the questions you'll expect. So both are alive. We have said you do what? Probability of wife alive, husband alive. You have gotten here. And so here is an and operation. You multiply. You go next. Both not alive. So husband dead and wife dead. You get that. Next is where is this one? One alive. So husband alive, wife dead, or husband. So these are some of the things you need to be checking as you calculate probabilities. So let's do another question, another example maybe. Let's see. So let's do number 2. Number 2 is an interesting one. Okay, don't worry about this advertisement. I just got this one online. Let's concentrate on the question. So we have a bag contains blue, green, and red pens of the same type in the ratio 8:2:5 respectively. A pen is picked at random without replacement. Always remember this part. This one here, without replacement, is a very important part. So a pen is picked at random without replacement and its color noted. So determine the probability that the first pen is blue, or the probability that it is either green or red. So this is very important for you to note. First of all, it's always good to break down your question. So you have been given the ratio. So probabilities can be given as ratios or, ratios or what? Or percentages or fractions. So those are just different ways of representing probabilities. So those are some of the ways you could represent probabilities. Apart from that, now you have the ratio of the probabilities of blue, green, and red. After that, you're supposed to understand the keywords without replacement is a very important part of this question. Without replacement. Very important. So take note of that. So let's go and break down this question in our solution. So a bag contains blue, green, and red in 8:5. That is the ratio. So number 2. We have a bag that contains green and red, the ratio at 8, 5 respectively. So the total ratio here, of course, is 15. So that means the probability of picking a blue, let's see what, 8, 15. So if you put your hand inside there at random and pick a blue, it will be 8 over 15. Then you have the probability of picking a green. What? Like if you're picking for the first time, it will be sorry. So we have done the first one. Sorry for that. Let me just take you back to the question. So the first question was what? Determine the probability that the first pen picked is a blue. So we've done that. So then the next one is, so is a blue, it will just be 8 over 15 over the total ratio. Then sorry for that. So this one will just be 8 over 15 over total ratio. Then number 2, here you have either green or blue. So let's go back to our board. That the first pen picked is either green or blue. So first of all, we know that probability of getting a green will be 2 over 15, and probability of getting a red will be what? 5, 15. So we have said A, the probability of a blue, let me just represent it like that simply, but don't be blue is 8 over 15. Then B, probability of getting a green or a red. Okay, so it's or a red. Remember these are so this one will just be getting the green plus probability of getting the red, which is 2 over 15 plus 5 over 15, which gives you 7 over 15. So you have a green or a red with a probability of 7 over 15. So that's the probability that the first ball you picked was either green or red. Then let's look at the next part of the question, which I think it's more interesting. So next part, they're telling us, using a tree diagram, determine the probability that the first 2 pens picked are both green. And then number 2, that only the first 2 pen picked, only one of the first 2 pens picked is red. So you first of all draw your tree diagram for picking the first 2 pens. And this is where you have to remember without replacement. Now let's just draw that tree diagram before we go back to the question. So you can pick, let's assume this is the first picking. So in the first picking, you can either pick a blue, a green, or a red. So probability of picking a blue is 8 over 15. Probability of picking a green is 2 over 15. And probability of picking a red is 5 over 15. So that is the first picking. So you can either pick a green, blue, or red. But once you pick a blue, you can still go ahead. Now the second picking, you will still pick blue, green, or red. But remember, we said what? Without replacement. Very important. Without replacement is key. So when you pick the first blue here, this one, you remain with 14 balls. And you've already picked one blue. So the next time you pick a blue, there will be 7. So the probability of getting a blue will be 7 over 14. Then the probability of picking a green, because this you've just picked a blue, the next green will be 2, but over 14, because you've already removed one ball. Then finally the red will be 5 over 14. So those are your probabilities. The next is if the first ball you picked was green, you go ahead and have red. Squeeze, try to squeeze so that it fits. So blue, green, red. So once you've picked a green ball, you remain with 14 balls, but you've picked a green as your first ball. So when you're dealing with this, line, you assume who think now that they removed one blue, now they've removed 2 balls. No, these two are independent. So once you have that, picked one green, you remain with 14 balls. So the blues will still be 8 if your first ball was green, but now over 14. You've picked one green, so you remain with one green over 14. Then the reds are still intact, 5 over 14. Then finally is red. So so if you pick the first red, the next one blue will be 8, green will be 2 over 14. Then finally red, you picked one, so you remain with 4 over 14. So remember here you have picked blue and blue. Of course, if you like making your work easier, you can just go ahead and this is a half times 8 over 15. That is 4 over, okay? But no need for doing that. So the next one is blue, green. The next one is red. Here you picked the first ball is green, the next ball is blue. First ball is green, second ball is green. First ball is green, second ball is red. Here, first ball is red, second ball is blue. First ball is red, second ball is green. First ball is red, second ball is red. So you have your probabilities. And let's go back to the question and understand. So you have drawn your tree diagram, and you've seen the way it's so interesting and easy to draw a tree diagram. Okay. So next, you answer your questions. The probability that the first 2 pens picked are both green. Both green. Remember keywords. Both green. So the word here is both. So the probability that the first 2 balls picked are both green. So it's when the first ball picked is green and the second ball picked is green. So this is the probability we are interested with. So probability that the first ball is green and the second ball is green. So remember, that will be the first ball is green, the probability is 2 over 15 times the probability that the second ball is green is 1 over 14. So due to without replacement, 1 over 14. So that is 7. So it's 1 over 105. Okay. Then part B. So we need to go to the question. Part B is the probability that only one of the first 2 pens picked is red. So one of the first two pens picked is red. So that means when it's both red, red, that is not an option. Only one of the first two pens picked is red. So some students fear these questions with so many words. Don't fear them. So only one of the first two pens picked is red. An example is one of the first two pens picked is red is here. This only one is red. You can see here. In this second option, let me just change the color. Sorry. So this is the first one. So only one of the first two pens picked is red. Here only one of the first two pens picked is red. Sorry, green, red. So here next is only one is red. So you see this is red, and here this cannot be an option because two of them are red. So as we see there, the probability only one of the first two pens picked is red is probability it is blue, red, or green, red, green, or probability that is red, blue, or red, green. Or so this, of course, will become what? Will be probability that is blue, red from our tree diagram. It's 8 times, sorry, where is the red? Times 5 over 4. It's 8 over 15, 5 then 4 plus green is 2 over 50 diagram times what? Red is it will be 5 over 14. That's going to 14. Next, our red is 5 over 15 times blue. They are 8 over. If you go back to your what? Tree diagram. Then the next one is red, green, 5 and 2. 5 over 15 and 2 over 14. So 5 over 15, 2 over 14. So you have those ones. 15 times 14, what is it? Sorry for doing that, but I'm not in the business of cramming multiplication. 20, that is 6, okay? 0, 11, 1, 2. So 40 over, I hope I'm correct with that multiplication. 10 over 10, this will be 40 over 10, will be 10. So this one can be simplified, by the way. How is it being simple like that? 5 is 1, 5 is 3, 2 is 1, 2 is 4, 2 is 7. So that is 4 over 21. Yeah, that's okay. So you have over 21 plus 1 over 21. Of course, in exam, all of this step is unnecessary because we do that with a calculator. So 4, this is 5, 5. That will be, that is 10 over 21. Have answer. So you have your answer here. So this is the probability that at least one of the balls picked is what? Is red. So I hope that That is okay. If you have any question, post it on the comment side. Ensure to subscribe and like this channel because it's for you. Next question. Maybe I hope this one is a short one. This will be a little bit longer video. Let me find a real question that has a different format. Okay. The advantage of probability, it's all about gaining. Let's do this short one about tossing a coin because the number 9 question. The reason why I've skipped those others, they're just similar to what we've done. So let's start with number 9A. An unbiased coin with two faces, head. So when it's unbiased, that means it can be a head or a tail. The probability of getting a head and a tail will be then head and tail is tossed 3 times. List all the possible outcomes. Hence, the probability of getting at least 2 heads and only 1 tail. So, take note. Unbiased coin with 2 faces is done what? Is tossed 3 times. So find, so 3 times. Let's just get up to there before we even solve the question. I know there are people who can do that often. You don't need to draw a tree diagram, but for me, let me just draw for you. So that is part A of the question. So unbiased coin is tossed 3 times. So the first tossing, if you toss a coin, you either get a head. So a head, if it's unbiased, you get a head with a probability of a half. If you toss the second time, after getting a head, you will still get a head or a tail. Same if you toss after getting a tail, you still get a head or a tail. So half, half, it's unbiased. Then the third time you'll still get a head or a tail. Half, still get or a half, still get a head or a tail. Sorry, one tidy. Always make sure your work is clean, my people. Finally, a half, a half. So here you get head, head. Here you get head, tail. Here you get, just change these colors so that people can follow me through. You'll not be having so many colors in your exam. Head, head, tail. This is head, tail, head, tail, tail. This is tail, head. This is tail, head, tail. Mathematics can be music. This is tail, tail, head. This is tail, tail. The advantage of things such as probability, for those who want to be engineers, like communication engineers, will apply probability very much to design your mobile phones and different systems in engineering. You do a lot of probability. So you have your tree diagram for 3 tosses. Then next is, sorry, they want you to do what? They want you to determine the probability of getting at least 2 heads and only 1 tail. So let's go back. At least 2 heads and only 1 tail. So probability of getting at least two heads. Let's see. At least two heads. So here we have three heads. So that is at least two heads. Here we have two heads and one tail. So this one will also have at least two heads. This one also has at least two heads. This one, no. This one has at least two heads, one tail and two heads. These others, no, no, no. So you see, you're getting at least two heads given by the probability of having all the three heads, or the probability of having the first two and the tail, as you've seen on our diagram, this one, or head, tail, and what? Head, or what? The other one, tail, head, and head. The good thing about this one, all the probabilities are the same, half, half, half. So here it will be a half, then plus a half. Okay. If you do a lot of practice, such things you will not need to write them. You'll just be able to put them down often. So this is 1/8 or 1/8 or 8/8, which gives you 4/8, and 4/8 can also be written as what? 2 over, sorry, for that you work. Okay. Can also be written as 1. So yeah, probability of getting at least two heads is 1/2. Let's go back to the question. The next one is at least one tail. I hope it's that way. The probability of getting only one tail. Only one tail. Remember, this was at least. This is only. These are very important words. Only one tail. Let's go back. Let's go back, people. Only one tail. So you're getting only. Let's go back to our question. Only one tail. This one has one tail. This one has one tail. So because this has no tail, this has no tail. This has two tails, so it fails. This one has one tail. This one has two tails. This one has two tails. This one has two tails. So we can write it as probability. Sorry. So this one will be the probability of getting our head. Sorry for that. Sorry for that. Just follow that order in which they are on my. So it's head, head, tail, head, tail, head. Or probability of getting tail, head. There are only three. There are only three. Remember, from what you've done before, all these are half. So this is a half. Times are the ands, multiplication, and then or the addition. 8 plus 8, 8 or just 1 over 8. It's 3 over 8. You have your answer there. So you've done it. At least only one head, one tail, sorry. So there is only one tail in each of them. Only one tail, only one tail, only one tail. So all these are what we call events by the event. So a head is an event. So when you toss a coin, you get a head is an event. So these are different events. Then this is the whole of this is your probability space. So that's just all the events. Okay, and let's see if we can do like one last one. Yeah, that's a lot of time I've spent. Okay. Yeah, let's stop there. So for the others, you can just get time and do them. I think we've done a good number of examples. Maybe I'll do another probability example to cover up the other questions because there are so many here. But let me know if you have questions. Unless there's one in. Oh, but that question had a part B. Yes, it has a part B. So they're saying, sorry for that. During a certain motor rally, it is predicted that the weather will be either dry, D, or wet. The probability that the weather will be dry is estimated to be 7 over 10, and the probability that for the driver to complete the rally during dry weather is estimated to be 5 over 6. The probability for the driver to complete the rally during wet weather is estimated to be 1 over 10. So complete the tree diagram below. So you have your tree diagram. Now let's just go. That's an interesting question. So B, we have the weather can be wet or dry. Sorry. We were using different symbols. Yeah. Weather can be dry. Because this is a question where you've already been. Then during dry weather, the rally driver can complete the race or can not complete the race. Wet weather still can complete or not complete. So we've been given here as 7 over 10. It's the other one. So you've been told that the probability that the weather will be dry is 7 over 10, which is given here in the example here. Then the probability, so we've been given it here, 7 over 10. Then the probability that the driver will complete the race is estimated, will complete the race when the weather is dry is 5 over 6. So this one will be 5 over 6. Sorry for that, it doesn't look nice, but we shall do it anyway. Then you've been given the 1 over 10. So if it's wet, it's 1 over 10. So I hope you remember that part. So the probability that will complete the race when it's dry is 5 over 6. When it's wet, 1 over 10. So they say complete the probability tree diagram. So always know the sum of probabilities. Sum of probabilities equals to 1. So this one you can write it as sum of all probabilities is equals to 1. So for us to complete, the probability that it is wet will be 1 minus 7 is 3 over 10. So subtract from 1. That's 10 over 10 minus 7 over 10. Then of course here it will be 1 minus 6 over 10, which is what? 1 over 6. Sorry, 5 over 6. 1 over 6. Then 1 minus 1 over 10 will be 9. So you have your probabilities. And this is space, or the events in the space will be dry and complete, wet and complete, wet and not complete. Okay. Then we go back to the question and understand what are they asking. What is this they want from us? So you see, probability is just easy. Like, subscribe. I know. So what is the probability that the driver completes the rally? So let's start with that. The probability that the driver completes the rally. So next, one, probability that driver completes the rally. So this can be here. Here you see the driver completes the rally. So it's dry and completes the rally, or it's wet and completes the rally. So you take those two events. So it will be the probability that it's dry and he completes the rally, or the probability that it's wet and he completes the rally, which from our tree diagram is 5 over 6 and 7 over 10. So this will be that is 7 over 10, 5 over 6, or that it's wet, which is 3 over 10 times that he completes the rally if it's wet is 1 over 10. This gives you 5 over 6 plus 300. Okay. The weird things I don't like. So I don't know. What do you do? You just do the long traditional 6,000. 16 to 6,000 is what? 100. Sorry, 6,000. Let's use 600. Sorry, Ashkadao. So 16 to 600 is 10. So this is 50. Then plus 100 into 600 is 6. Then this is 18. So it is 600. Simplify that fraction at your own free time. Yeah, but that is the probability. Of course, this one is just do with a calculator. And I told you I didn't have a calculator. And I don't want to think as much. This is supposed to be my break time from my studies. And then the next is the probability that the weather is wet and the driver did not complete the rally. So it's wet and the driver did not complete the rally. Kindly take note of keywords. It's wet and the driver did not complete the rally. Let's see. So it's wet and driver did not complete the rally is this one. Wet and did not complete the rally. So you take this event, so and did not complete the rally. So that will be wet and driver did not complete the rally. The probability that it's wet is 3 over 10 and did not complete The rally is 9 over 10. So 3 over 9 over 10, which is 700. Others will write it as a decimal, 0.27. So you have a good luck, success in your KCSE. Like this channel, subscribe to it, do a lot of practice, get questions, ask me questions on the comment sides, and I will answer them for sure, for sure. Have a nice time. Let's meet again next time. God bless. And don't give up. Don't be scared by Corona. Keep working. You are